Hi, it's Carly McAvoy talking about rational expressions, and in this video especially we're talking about finding the least common denominator. Just with other fractions, you need to have a common denominator in order to add or subtract terms. Remember the three things that you can encounter when you're finding a common denominator. The first thing that you can find is that the denominators have no common factor. In that case, you just multiply the denominators together to get a common denominator. Back when we weren't talking about variables, we would have maybe had something like 1/3 and 1/4. The LCD, because these are just two numbers that have no common factor, would be 3 times 4 or 12. In this one, where we have variables, we have x, we have y squared. Those represent different numbers, and so we're just going to then say that's going to be x from this term, and then y squared, x times y squared, because they're two distinctly different numbers. X plus 3 and x plus 1 are two different numbers as well. They both have an x in there, but if we found out x was 5, 5 plus 3 would be 8, 5 plus 1 would be 6, let's say, and those are two different numbers, so we can't say that they have a common factor when we don't know what x is. So we just write those side by side, x plus 3 times x plus 1. So no factors in common, we just multiply the denominators together. The second thing that can happen is one of the denominators can actually be the common denominator. The denominators share a common factor, and we don't repeat that when we write the LCD. For instance, back in the day, we might have had 1/4 and 5/8. We know that 4 is actually inside 8, so there's a common factor of 4, but we don't show the 4, we just show the 8. The 8 represents itself, it also represents the 4 there. If we have something where we have variables, and the same variable represented in both denominators, we can say there's 1x here, there's 1x in here too, plus 2 more. And so the LCD is always going to be the variable with the highest power that we see between the two denominators. So x to the third is the least common denominator, which was contained in one of those denominators. And in this one, we have two different binomials in the second one, x minus 1 and x plus 1, but that x minus 2, I should say, is represented here as well. So x minus 2, we don't need to repeat that twice. We just show the x minus 2 because that's something that shows up in both of those, and then the x plus 1. That would be the LCD. And then sometimes the denominators are different, but they contain a common factor, but neither one of them is the LCD. We still don't repeat that common factor. So for instance, 6 and 9, if we broke that down, we'd see that's 2 times 3 and 3 times 3. They both have a factor of 3 and then something else. The 6 has a 2 and the 9 has an additional 3. That 3 that they have in common is not repeated, so we have 2 times 3 from the 6. That 3 is already represented, and then we multiply it by the other 3, giving us the LCD of 18. That's something that looks familiar. This might look a little less familiar. We have 3x and 5xy. The 3 is unique to this denominator. The 5 and the y are unique to that denominator, but they both have an x. We don't put x to the second power. We say they have a 3, we need a 3 and a 5 because those are the two unique numbers. We have this common x, and then we have this unique y. So we multiply that together to get 15xy. And finally, in the last one, we have two binomials, and then we have a monomial and a binomial. Well, I need x plus 2 and x minus 1 in my denominator to represent this fraction. And if I were to write that, I could just write that side by side. And then when I look at the next one, I have a standalone x, which I didn't have before. So that would be included in my LCD. I have an x minus 1 that's already represented, so I would not repeat that, and my LCD would be x times x plus 2 times x minus 1. Find the LCD for the following pairs or sets of expressions. Pause the video and try these on your own. I'm going to go ahead and work through them. Hopefully you've taken a second to pause. So for the first one, we have 15x squared and 25x to the sixth. We should recognize that they do have some common factors, but neither one of them is exactly the LCD, because 15 is 3 times 5 and 25 is 5 times 5. We don't repeat that 1, 5 in the middle. And then we have the same variable, and so we always use the highest power when we're doing that. So that would be 3 times 5 times 5 is 75x to the 6th. We always use the highest power in the LCD if we have the same variable. For the second one, we had 3x minus 2 and 6x minus 2. Maybe you recognized in this one that we have one of the denominators is our LCD, because 3 is 3 times 2 and 3 goes into 6, and so our LCD is 3 times 2, which is 6, and our LCD contains the x minus 2. So we don't repeat the x minus 2, and we don't repeat the 3 that showed up in both of our terms on the outside. In C, we had two distinctly different terms, t minus 4 and t plus 4. So when we have two different terms, totally different numbers, we then multiply them together. So we would just multiply those two things together to get the LCD. And the last one, we had 2t plus 1, 3, and 2t. And the LCD here is 3. We usually put our numbers in the front. So I'm showing you that tradition, and then any standalone variables, and then binomials. That's how we usually write that. And so we have the 3, we have a 2t, which is a totally different number than 3, and then we have 2t plus 1, which is different than all of them. And so if I just multiply all those together, I get 6t, 2t plus 1. Again, that is 3 distinctly different individual expressions that have no common factors. And remember that 2t by itself and 2t plus 1 are very different. If we found out that t was 4, 2 times 4 would be 8, but 2 times 4 plus 1 would be 9. Those are representing different numbers. All right, have a fantastic day.